How's it going, everybody? This is Ridiculously Awesome Machines. This is going to be the first video for this channel. This is my first time doing a proper video. So, just so y'all know, I'll have plans to, make stuff look better in the future. But for right now, this is going to be just the first video. Uh, this is a channel that is designed for explaining computers and laptops and basically how they work, just so everybody can get an understanding, even for people that have no clue, like have never had anything to do with computer before. This channel is going to be designed to show people the components and how it goes together. um, I will have videos in the future of me putting computers together, but these are going to be basically simple lessons, showing people like the different kinds of components that you will find when it comes to computers. Um, and then I will also be building a computer eventually and do it on video for y'all. Uh, when I get the time, I will pull my computer out from where it's at, and I will basically show people what the components look like for a computer that's assembled. Obviously, I've built my own computer. That's how I'm making my video here for y'all. Uh, but for now, I'm going to go through the components. For people that might know who I am, I stream video games. I have a separate channel and a Twitch channel that I stream games on called Buzzy Fizzy. I will add the links to my streaming if you all want to watch any of my videos. But for now, we're going to focus on components of computers. I'll give you all a small background. So I'm not, I for a long time I wasn't, a super nerdy person. I never really got into computers, but as console prices rose, I started looking more into computers because when I started built with my computers, I had no clue what I was doing. Had no clue about compatibility. Had no clue about the type of stuff you needed for computers, and so I took a lot of time to learn about the different components of computers and what they do, and I learned about compatibility, because a lot of the things that people run into when they're unexperienced with computers is that they will run into compatibility issues. They'll not know that you need certain types of components for other items. So one of the biggest ones I see is with the motherboard and the CPU. Sometimes people will think they have the right motherboard, but then they have the wrong CPU, or they buy the CPU and they get the wrong motherboard, because every CPU is different. There's different sockets for different motherboards, but that's going to be a different video. For now, we're just going to go through the main components of a computer. This is just baseline stuff you need to be able to use a computer. So for components, starting off, we're going to start with the case. Your case is what makes your computer. It's what holds everything in it. Your case is going to be your choice. It's how you decide to build your computer, basically. So if you're wanting a full size computer, then you can fit way more stuff into it. Or if you want to have like a small computer, something that you can easily move, something that is a little bit more budget friendly, then you can go with a small size form factor. So like I said, all these components we're gonna go through in different videos, and there's gonna be a playlist. It's probably not gonna be very long videos. The main majority of these videos is just gonna be going through explaining the different components, and I'm gonna try and lay it out in a very simple manner that people can understand. And obviously, for people that might still struggle, I have also made it so you can easily email me, and I can also explain to you, if say you're trying to build a computer, I can explain to you components. I can email you and help you if you're struggling building a computer, or if you're having issues with a computer, because sometimes there can be issues between components. May not be compatibility, but it may be um, power issues, or it may be the type of RAM you're using. There's all kinds of issues that could be happening. The next thing I will cover is the motherboard. The motherboard is your building block. Once you have your case chose, for now's when you can choose, the kind of motherboard you want. So generally, the case and the motherboard can go hand in hand. You can do one or the other first, because your motherboard is gonna basically it's gonna dictate your case size. So there are multiple different sizes of motherboards, and we will get to that. Like I said, in another video. But your size of your motherboard will dictate your case, and vice versa. The size of your case will dictate the size of your motherboard. So if you want a really cool case, just remember, you also got to remember that you need to, whatever that case is, you need to look at what kind of motherboard it fits. Because if you get a large case, it can fit any size of motherboard. But if you get a small form factor case, it's most likely going to fit a small motherboard. And obviously these motherboards, they have different names. For example, my motherboard is a ATX. ATX motherboards only fit usually into a mid-size to large size case. But if you're doing something like a small computer, then you might need a ATX, or you may need a micro ATX or a mini ATX. And then we'll move into the next part. So we're gonna have the CPU. This is the brains of the computer. So your CPU is, again, it's gonna be dictated by your motherboard. So CPUs, there's generally two types of CPUs. There's two manufacturers, the main ones that you see for computers. You have Ryzen and you have Intel. The thing is, though, with those components, like I said, it's compatibility issues that people have a lot of trouble with. For the CPU, you need to make sure that whatever generation of CPU you're getting matches with the socket of the motherboard. And you also have to make sure the motherboard is correct. Because I've seen times when people will buy an Intel motherboard, but they buy a Ryzen processor. And for obvious reasons, the socket for that motherboard is not going to fit the CPU. And then if you'll, just so everybody here can get an understanding, for anybody who is watching, the CPU, like I said, it's going to be another video, all these components. The CPU is going to be the central processing unit. And that's why it's the brains of the computer. It's literally what allows the computer to think and do everything it needs. But the big thing is compatibility. Compatibility. You always have to remember that when you're looking at components, that they match correctly. The next is going to be the GPU. And GPU is your graphics processing unit. It's the visuals. It's what allows you to see. Now, depending on what kind of motherboard you get and CPU, can actually dictate if you need a GPU or not. Because they do make CPUs that have integrated GPUs. Meaning that your CPU not only does the thinking for your computer, but it also does the visuals. Now, there's going to be, a performance that you're going to have to, think about. Because if you're doing a gaming computer, if you're specifically building one just for gaming, then you might want to consider having a CPU and a GPU. But if it's an office computer, then you might want to consider saving the money instead of spending it on a CPU and getting a good CPU with integrated graphics, because then you can use it for office work and it'll still be a good CPU, so you won't have as much graphic potential without the computer slowing. But with a CPU with integrated graphics, office work becomes easy, especially if you save the money on a GPU and get a good CPU. On the other hand, if you have a gaming computer that you're trying to build and you're all about graphics, then getting a GPU to go with your computer is also going to be important, because a GPU will be its own dedicated graphics. So you no longer have to worry about the CPU overworking itself for graphics. The GPU will do all that for you. And so it'll do all your stuff, so you can go from, instead of doing integrated graphics, you can do way better resolutions using a GPU if you're doing a dedicated GPU. So it's all about what you want from your computer and what it's going to be used for. Next is going to be the PSU, the power supply. This is what powers your computer. It's for an example, it's the mitochondria of the computer. It's the powerhouse. It is what powers everything from your motherboard to your CPU to your GPU to all your storage, everything. It powers everything in your computer. And the big thing that I see with a lot of pre-built computers is they short you on your power supply. They give you the bare minimum for your computer. They don't give you a lot of wiggle room. The big thing about your power supply is you want to make sure that your power is adequate, one, for your computer, but also for possible improvements in the future. So if you decide you want to upgrade your CPU, or you want to add more storage, you always want to make sure you have more power, because the last thing you want to do is make that power supply run a lot higher than it needs to. It doesn't need to. You shouldn't have a power supply that's literally pushing out as much power as it can just to power everything in your computer. So, always choose your power supply wisely for what your build is. The SSD and the HDD. So, what do those stand for? Well, the SSD is a solid state drive, and the HDD is a hard drive. So, what those are your storage for your computer. It's what allows you to save all your data, save documents, download video games. It's what allows you to do a lot of the stuff that you want to do. In the video for storage, when we cover it, I'll tell you the difference between the SSD and the HDD. The main difference, I'll tell you right now, is an SSD is all digital. It means there's no physical writing. It's all zeros and ones for data. Hard drives, on the other hand, are different. Hard drives have a disk inside of them. So what happens with that disk is it writes data on a disk, and that's what keeps the storage for a hard drive. And there's differences between them, because for SSDs, they're faster because it's all numbers, but they also cost more money. Hard drives, on the other hand, they're cheaper because they use a disk, meaning that they're going to deteriorate over time. So they're cheaper. They're also cheaper to make. With hard drives, the main thing you want to worry about, though, is because it's on a disk, every time you write data on that disk and then delete it, it wears down that disk inside of it. And also, they're very sensitive. So if you drop your computer or you just drop the hard drive, it could totally destroy that hard drive. It may not look like it on the outside, but on the inside, if that disk gets warped or destroyed in any way, that hard drive becomes completely useless and all the data on it's lost. SSDs, on the other hand, are all chips. So the only way to destroy an SSD is like completely destroying it. So SSDs and hard drives, they have their benefits, but they also have their cons. Fans, AIOs, and pumps. What is that for? Obviously, it's a computer. If you don't know, it runs off electricity. So electricity obviously is going to get hot, and especially the CPU. Your CPU, the brain of your computer, it's doing so much processing that it makes heat happen. Same thing with your GPU. Most of the time, though, with GPUs, they have fans. Your CPU doesn't have a fan that comes with it, so you have to get one. So for fans, generally you want to have a intake and an outtake, kind of like a car. A car has an intake and an outtake that allows the engine and the coolant in your car to, transfer that heat, so it's no longer, overheating the engine. Computers are the same way. You have to have enough cooling in your computer to allow it to basically to breathe. Because if it overheats, depending on, your computer, a lot of modern computers don't have this issue, but older computers, if they overheat, it will fry the components in your computer, and all that money you put into the computer will be useless because the components are fried. So generally, your cases, you also want to make sure you have enough room for fans, and then also for cooling for your CPU, which is when an AIO comes in. So for a CPU, there's 3 types of way to cool it. You have fans, which is where it has a big block of aluminum with a radiator on it. It looks almost exactly like a car radiator, but it's designed to go directly onto the CPU. And what the fans do is they blow air through that radiator, which distributes the heat, because the heat coming off of the CPU goes into the radiator, and then the fans blow the heat out to cool down that radiator, which allows the CPU to constantly stay at a good temperature. Then you can move into water cooling. I know, sounds crazy. Water inside of an electric device. But The reason you can do water cooling is because air has a lot of. We're gonna get real sciencey here. Air has a lot of factors that can affect it, and so it causes heat to not distribute as well as water. Water has a better heat transfer. So the reason you do water cooling in your computer is so you can move heat a lot quicker and a lot more efficiently from the CPU to keep it from overheating. So there's different ways to do water cooling. You have a pump system, which is where you have to get a separate pump that you attach inside your case, and you can do normal hose tubing, which is rubber tubing that'll go over the CPU cooler, and then it rotates through the computer. And what that does is there's a radiator, there's a pump, and then there's the actual CPU cooling copper piece that goes over top of the CPU. And what that does is it allows the water to rotate around the CPU, and it moves it from the pump to the CPU to the radiator, and then the radiator has fans on it that blows the air out just like it would for a normal radiator, just an air radiator. But this is a water one, so it's moving that water through the radiator a lot quicker and a lot more efficiently to move that heat, and then the fans simultaneously are blowing on the water in the radiator to dissipate the heat out of it, which is the same way that a car works. It moves your coolant through the radiator, so then when you're driving down the road, the air goes through the radiator and dissipates the heat. And then the last thing is a AIO. What is that? It is a all-in-one pump. So generally AIOs are designed to have the pump directly on top of the CPU. And so not only is it transferring the water from the plate that's on the CPU to the radiator, but then it's also pumping it at the same time. So you don't have to have a big fancy system in your computer. You can just have an all-in-one. And it comes with the pump, the hoses, and the radiator all attached. And it's a lot smaller. There is a thing you can do with a full pump system though. So instead of using rubber tubes, you can use acrylic hardline tubes. The reason you might want to use those is because you can mold acrylic tubing to basically fit your case how you want it, so you can make it look however you want, compared to rubber hoses like an AIO or a normal rubber hose pump. They're going to, obviously it's rubber, so it's gonna move in ways that you might not want, but it's what it does. I personally use an AIO for my CPU because I don't like dealing with acrylic tubing, because there's a lot more in depth with it. Acrylic tubing involves having heat, having the proper instruments to curve or bend the acrylic as you need, and you also have to make sure that you have gaskets and attachments for your pump. And the other thing with acrylic tubing is, because it's acrylic, there's a chance that when you turn on the pump, you could not have a good seal, and it could leak. So you always want to make sure that you choose the best thing for what you believe is the best for your computer. I would always recommend an AIO to anybody that asks me. But obviously, a normal fan radiator for your CPU is also never a bad option. But you also want to consider fans for your computer as well. So it's a big thing to think about. And then the last thing we'll cover just for the components, for the basic components, is your RAM. Your RAM is what it talks to the CPU. The CPU runs numbers and it runs calculations and processes your computer, but it also shoots those numbers through the RAM. And that RAM, it crunches those numbers. It's like a second brain on the side that helps the CPU think. And your RAM is also what allows you to basically run multiple processes at once. So your CPU processes all the data, but your RAM is what allows you to run multiple applications at the same time without bogging down your computer. So a lot of people, especially for pre-built computers, or if you ever done on school computers, you'll see when the computer starts kind of buffering, like you get onto an internet page and you're trying to open up multiple and now it's slowing down. That's because your RAM is what helps you be able to maintain those applications at the same time. And without your RAM, your computer, you're putting all the work on the CPU. And that's why most of the time the computers, you have to have RAM. And then your RAM, how much RAM you need depends on your computer. So obviously if you're building a just strictly work-related computer, you want, I'd say between 8 to 16 gigabytes of RAM at most. Most likely you'd only need about 8. For a gaming computer, normally the bare minimum you want is at least 16 gigabytes of RAM, because games take a lot more of that processing power, and that's why they also need more of that RAM, because your RAM is basically your middleman between the CPU and the GPU. So it's basically trying to run all this stuff at the same time, and that's why you need your RAM. I personally use 32 gigabytes of RAM. Most of the time you only need about 16, depending on the game you're playing, because most games don't require more than 16. The last thing I will say, which is not on here, is your BIOS. Or not your BIOS, but your OS. Your OS is what runs your Windows or your Linux. What is Windows and Linux? Windows and Linux are your basic operating systems. That's what OS is for. It's your operating system. Your operating system, it dictates, how your computer works. Windows is the most common one you'll see, because Windows, it's a very common one. It's a simple system. You're not going to see it a ton, but you are going to see Windows a lot more than you'd see Linux. Linux is an OS that's more designed for coding, because Linux is a lot looser with its coding compared to Windows. Windows is a very tight-knit operating system, so generally the most you can do with it is pretty much what I'm doing, office work or gaming. Linux, you can go into coding and a lot more in-depth stuff, and you can also modify your OS with Linux. I personally use Windows. I think Windows is one of the more preferable ones, and it also is a way easier one to install. Linux, it's not super hard, but I would always recommend Windows for somebody. And then obviously there's different generations of Windows. Most computers these days run on Windows 11. But you could always go to any version of Windows you want. Hell, if you wanted to, you could install Windows Vista. That's a completely doable thing. Would I ever recommend it? No, because having Windows Vista on a modern computer today is a little bit redundant. And it's something you will basically never see anybody do unless they want to use an old system for a certain reason. But most of the time, most people nowadays are running Windows 11, or there's some people that might run Windows 10 just because they like it better. But you can always, anytime you install Windows, you can always upgrade to the next version. It's always a doable thing. Personally, I just install Windows 11 right away. I have a flash drive that has a full version of Windows 11 on it that I can install on any computer at any time, because what I did is I bought a key, and when you buy a key, if you put a version of Windows on a flash drive with a key, you permanently have an OS that you can always install onto any computer if they need Windows. So that's a big thing, is if you're going to be big into building computers, you might want to consider putting a full version copy of Windows onto a flash drive that you can always just put onto somebody's computer, and then they never have to worry about paying for it if you're building it, because you always have a full version of Windows on a flash drive. Compared to if you downloaded Windows 10 and then decided that you wanted to upgrade, now you have to pay for a key to upgrade your computer, because Microsoft loves making money. So, am I going to bash Microsoft a little bit? Absolutely. But yeah, this is just the basics of how a computer is built. And more or less, we're going to get into other videos. I'm going to go into each of these categories, explaining the different types of cases, motherboards, CPUs, all that. And I'm also going to give you all the pros and cons. And by the time we're done with this, we're going to build a computer. Because my entire plot for this channel is to be able to build computers, and one, I'd like to build computers for people. So if you ever have a computer that you want to get built, you can email me, and what I can do is I can you give me a budget, and you give me what kind of computer you're going to use it for, and I can give you specs and a price. And my plan is I can build your computer on video, so you can see it getting built, and also so other people can learn about how to put a computer together. That's my end goal for this channel. But for now, hopefully you all enjoyed a little bit of explanation on at least the components of the computer. And in my next video, I will elaborate. Most likely, I'm going to go in the order here. So my next video is most likely going to be about cases. So.